the Executive Director of PCI of Illinois and Wisconsin, and the moderator for today's webinar. Today's presentation is sponsored by PCI Illinois, Wisconsin, PCI Midwest, and PCI Mountain States. Our goal is to bring a greater awareness of precast concrete to the design and construction communities via quality continuing education programs. Before I turn things over to our presenter, let's review a few housekeeping items. First, you can submit any questions by typing them into the questions pane on the GoToWebinar control panel. You can submit your questions at any time, but we won't be addressing the questions until the end of the webinar. You can download a PDF of the presentation via the handout section on the GoToWebinar control panel. Don't worry if you can't find it, because links to the handout and a recording of the presentation will be also emailed to you after the webinar. Attendees who have fully participated in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit. You must be logged in and attend the majority of the presentation to receive a certificate of attendance. A link to the certificate will be emailed to you within 10 business days. If you provide your AIA number when you registered and you attend the majority of the presentation, we will report your attendance to AIA for you. If you're currently viewing this in a group setting where only 1 person is logged in to GoToWebinar, you will need to email Margaret Mills with the names and the contact information for everyone with you, or she won't be able to send the certificates of attendance to the other people. The course description and the learning objectives were listed in the registration process, so we won't take time now to read them. And remember, we'll answer the questions at the end of the presentation. Finally, let me introduce our presenter we have today. As a forensic architect registered in several states, Corey Zussman has practiced in the construction industry for more than 30 years. He specializes in building envelope, restoration, preservation, life safety, and interior finishes. While working on an average of 50 to 75 projects a year, Corey conducts constructability reviews, pre-installation meetings, comprehensive envelope meetings, and construction observations. He's also become known for providing educational opportunities throughout the industry and has produced more than 150 lessons learned papers. Topics include building envelope and life safety concerns that enables Corey to proactively address issues during design review, pre-construction, and construction. In addition, he has over 10 industry articles about building envelope and life safety topics, and is also a frequent presenter at local and national conferences and associations. And with all that, the show is yours, Corey.
Thank you, Joe. I appreciate that. Good afternoon, or good morning if you're in the Mountain States. We're going to talk about constructability of precast concrete part 2. So this is piggybacked on to what I did in, I forget, September or October, a few months back. So it follows the same format. So I'm going to continue here. And I'm not able to advance. There we go.
Corey.
Okay. Yes.
I was just going to say, click on the PowerPoint and it'll know that you want to do.
Yep. Now we're good. Thank you. Okay. So like all of my presentations, there are lots of different ways of doing things, lots of different options out there. I'm just going to be showing you my opinion based on my experience. So lots of different ways of doing things. Just keep that in mind. So, precast has just the ultimate design flexibility. It can do and show so much. Shadow lines are extremely interesting. They can interact with different materials. This is actually interacting with cast in place concrete and a really complex precast shape. This one here is believe it or not, it's a precast veneer. So awfully difficult to actually do. It was not easy to make this work, but we were able to do, I think it was 45-foot high precast veneer. So The entire building envelope went on, insulation, and then we actually installed these precast elements, um, and um, and then we were done. Worked out really well. And of course, inset concrete, inset masonry, long expanses, industrial looks that just give you an infinite amount of possibilities. This is a medical office building. So, I mean, we use precast a lot in our construction, both for flexibility and for cost purposes. This is a real nice apartment building. I think this won an award. It was extremely intricate as far as the design elements go. It was beautifully constructed. We were very happy with that precast supplier. And I believe this is actually one of my favorite precast elements. It's we'll talk about it a little bit later, but it's a four-sided precast element that just adds a lot of little flair to a real simple addition to a school. Okay, so I'm going to begin the presentation, starting with mock-ups. We're a contractor that we absolutely want mock-ups. Mock-ups are important for many ways, many reasons. It confirms assumptions, it confirms ideas, and constructability of things. So this is a mock-up that we did for it was a 6 or 7 story medical office building. The shapes were extremely complex, like I showed before. But one of the real big things about mock-ups, in order for them to be truly useful, is that they need to address the actual condition that's on the building. So if you look at the mock-up I just showed you, you see how the precast elements are lining up or is somewhat offset in this one. So this one is, slightly proud of this one, but in actuality, they were actually quite proud. I mean, way proud. And we didn't anticipate even the drawings didn't. This is on an angle, this building, and the drawings didn't really identify this condition quite as extensive as it was. So it'd been nice if we were able to identify that earlier rather than trying to figure out what to do after the fact. But again, mock-ups. When you design mock-ups on your construction documentation, we do like to see drawings of it. We like to see what's expected. They should show as many conditions as humanly possible, but they need to reflect the actual condition. We we used, as a general contractor, we use the mock-up really for constructability rather than for visual. If we can do both, that's what we like to see. We also want to go a little further, and we want to mock up patches. So, we're always going to have some damage on the building. It's inevitable. So we want to make sure that the patch, which is going to be an integral part of it if the building's not being painted, um, properly matches. So sometimes even using the same mix design won't necessarily get us the best patch possible. And then there's always, you know, the installation of the patch. Is it being properly installed? What is the procedure? So, what I would recommend to architects is asking for the procedure in writing, not just a cut sheet for the product and their little installation instructions, but there's more to it than that. So if the contractor is able to provide you with a written description of how they're going to do the patching, personally, that gives me a better feel that they truly understand what goes into a proper patch. So this patch right here um, was not done properly. It dried out too quickly. We didn't properly pre-wet the area, and we didn't keep it moist during. I forget what it was. It was either 12 hours or 24 hours. So you can see all the spider cracking. And when you look on the highway, especially in Chicago, you can see this everywhere, where they try to patch the sides of bridges and overpasses and such. But you know, again, the mock-up is to confirm assumptions. It's to confirm to everyone that you understand, at least the subcontractor understands what everyone is looking for. So I can't express enough how important mock-ups are. You look for color, of course, and consistency and all that. And color, which is my next topic, most, especially deep tones, jewel tones, are going to have variation. It's really difficult to take a natural material and force it to be the same color over and over and over again, especially if it's multiple pours, multiple days. It could be over a large span of a month or more. So, how is that being handled? So the first thing I would recommend is asking for a color variation. Maybe get that color, uh, uh, the cast, over a series of a week or possibly 2 weeks, just so you can determine if that's what you're looking for. And if it's not, if you get variation like what we're seeing here, especially with blacks and reds, purples are really difficult. You can do things. The contractor has different ways to make these colors more consistent. There might be a cost to it, but it's something that at least everyone has the opportunity to assess if it's worth it. This one it's a huge color variation. I think you can see that one. And this next picture is a black color, and the color variation was nil. It was beautiful. It was a rather large building, 650,000 square feet, and each panel almost looked exactly alike. Very impressed with the supplier there. But they brought up the fact that, especially with black, they would have a problem, and they can potentially see what we're seeing here. So it was important to the owner, and he did end up paying a little bit more to get this finish. But again, we were able to see what the issues were because we did some mock-ups of both ways, and it was worth it to the owner for the added cost in this situation. So besides the mock-ups, these color mock-ups or color variations, that's something that should be done as soon as possible, because it could take some time to get those going. Here's again that building. It's not the building I just showed you, but the building that we did a mock-up of. The color variation is actually pretty good. There's a lot of shadows in this, in this particular panel, which I think helped the color variation. And it was deemed that it was an acceptable variation on the entire building, the way that it was going to cast shadow. So it worked out really well. I think the architect chose the right mix, and it went really nice. So with this building, we ended up doing a base or a first floor in cast in place concrete. I don't exactly remember why we did that, but that's how it ended up being. And there's always that chance, very good chance, of the color not being accurate or the sheen not being accurate, because the forming materials are going to be different. How the concrete panel for the precast might be, something that really needs to be discussed before you try and mix and match it with cast in place. I think we did okay. I think the color variation was, especially on that inset portion, not exactly what we wanted, but we did have the intent. We did actually use the same mix design. We did get material from the precast manufacturer as much as we can get in order to do the cast in place. It wasn't a huge area, but that was, something that needed to be considered. That maybe, just not on the, forefront of everyone's mind. So again, when you're mixing and matching, think about, how, what the concerns will be. Write a list. It's really the best way, and then we'll work with the precast and the cast in place concrete contractors and determine how they think it should go. What is their best opportunity? Get the concrete plant involved, because they're the ones that are going to be mixing the materials. So the more people that you get involved, the better. I think the better overall products you're going to have. So we do a lot of curve buildings, and the question always comes up: are we going to have our precast curved or segmented? Is the material above going to be curved or segmented, and or below? And all that is going to play a role in what we're going to see. So, for example, if our foundation here, it was segmented, but we segmented it in such a tight panel that it really looked curved. So if we use longer panels for the foundation for these curved precast panels, we would end up seeing a shelf, right? More shelf in the middle of the panel, less shelf or no shelf at the very edges, and that's probably not what would be desired. So we did decide to go with a very tight segmented uh, foundation wall in order to eliminate any kind of shelf or unnecessary view of the cast in place concrete foundation when we placed our curved panels on it. And then we knew how we were going to handle the windows. It was a relatively short span in this case, so it really didn't pose too much of an issue. But all of that needs to be taken into account. This is a curved building. This is the back of a panel, and the back of this panel became the parapet. So, how that parapet would be detailed and what materials that we use and how we install it is going to be critical, especially with the curves. So it doesn't make more sense if we use a radius or if we use a segment. So for example, in this case, we actually did a really tight segment, which you can kind of see. The intent was that we would have 1 foot installation panels, and then we would be able to follow the curve and just get a better form fit of the installation system to the substrate. Worked out really well. We were able to use peel and stick for the just for the vapor retarder at the parapet itself, and then we changed the vapor retarder to a torch applied after that because it would have been just too difficult to get the torch applied to make that all those turns and corners. So um, the question is, foundation, like I mentioned, but you know, where is this curved panel or segmenting panel? Where is it going to go? What's going up against it? And I'll talk about a little bit more about insulation. Insulation's pretty unforgiving. Roof insulation. It's when you use rigid polyiso or an XPS potentially, or even an EPS type insulation. It's those are pretty flat and pretty unforgiving as far as bending it. So that is something that needs to be considered. And then, the back of the panel, do we have to be concerned? In this one, we deemed that it wasn't really, we didn't have to have a super smooth surface. So, you can see a lot of watermarks here. These are water that was pooling in the forms. So this form, I think, was poured laying down, or I think that's how it was. But anyway, we deemed it wasn't necessary, but you may deem it that it is necessary, that you want it nice and smooth. So that would be a 3-sided installation. We'll talk a little about that later, but a 3-sided installation needs to have a conversation up front with the precast manufacturer. So let's talk a little about concrete embeds. So, these, we had a couple projects where the embeds became the most difficult portion of the project, if you can believe it or not. So, so here's a project where it was down south, and um, we didn't have the requirement at that point for them to pre-hang any of these embeds, which we do now, which I'll speak about in a little bit. But um, the contractor had these embeds off to the side, and he had a laborer come and put them in. They located them. The location of them wasn't really so much of an issue. It was the fact that they waited just a little bit too long. It was windy. It was warm. It was, I think, like 92 degrees. It was pretty windy. And by the time they installed those embeds with the studs on the back of them, they couldn't get them into the concrete very well. So they had to hammer them in, which I found out later as we were doing our investigation. So they literally hammered these things in, pushed the concrete down, and you can almost lift these concrete embeds with your hands. We ended up removing over 1,000 linear feet of footings that had these embeds because they were all bad, and we just couldn't make them right. So not a lot of projects have 1,000 linear feet of footings, let alone we had to remove them and start over again. So when we learned of the issue, we researched a little bit, and actually ACI 301, there is a section in the ACI 301 book that requires the placement of all sleeves, insert, anchors, and embedded items required to adjoin um, any adjacent work before or after that it needs to be placed in the concrete before the concrete pour for a very good reason. So for years now, that's been our requirement. We do not muck or place in any kind of embeds while they're pouring the concrete. I mean, for lots of good reasons. One is you can't verify very easily the location of those embeds. Once you get them in, it's rather difficult to place them back out. But again, you don't know when and how you're going to be placing these things. You still have to vibrate the concrete, which I'll get to in a second. But that vibration, as these things are mucked in, might settle a bit and be on an angle or tilt, and that's a problem. So we get lots of questions. We do a lot of um, uh, non-formed foundations or footing details, and the contractor always asks, how are they going to pre-place these? But the fact that there's no forms to set the wood on to hold these things. So we've come up with several different ways. Contractors, when you really push them a bit, they're extremely creative. But we were able to. It's not very difficult. Just get a little longer piece of wood, for example. You got to make sure that the embeds come with holes. That is one of the things that we did learn pretty quickly, that we need to specify the embed plates with holes so we can nail or screw them to pieces of wood to hang them. So when we don't, we end up getting a press out in the field, which is a little bit cumbersome, and then creating the holes. So it's much better if we're able to think ahead and specify that they have holes for presetting. Again, all embeds really should be preset. There's really no reason not to. It is required for the ACI 301, and there's always a way to do it. Now, all concrete needs to be vibrated, okay, regardless of what kind of concrete it is. So here's a footing. Footings need to be vibrated. Anything over, no, I forget what it is. So many inches, I forget, but it's very little. You need to vibrate the concrete. So here's a construction that we did. The contractor did not vibrate the concrete, and you can see all the honeycombing and pore consolidation. The structural engineer deemed that to be unusable and wanted it removed. This was only a couple hundred linear feet, but you can see on the picture on the right there, picture of the removed footings and our new footings going in right there. So it's a little heartbreaking. I like this photo because it really shows when I talk to a new concrete contractor, really the reason why we do what we do. But you can see the new footings are fantastic. They vibrated it quite nicely and really got those embeds. We know that they're in really good shape. We ended up taking a hammer to a lot of these, and they sounded hollow. We did a little investigation, and we were able to determine that at this location in this building, when we were getting those sounds, that we were actually seeing concrete just not properly consolidated around these embeds as well. So I'm just going to show you a couple details throughout the presentation that we've developed over time with precast manufacturers. And the first one is when we have a precast wall that is flush with the pavement. So the foundation wall doesn't go all the way down to the footing. There's actually, or I'm sorry, the precast wall doesn't go all the way down to the footing. There's a precast wall that sits on top of foundation wall. And there is a potential for ice, water, snow, and rain, of course, get the right one, to just flow right in, right? So if this sealant fails, and it will, we have two sealants in this case, but if there's enough push, if there's enough damage, we can get that to fail. Our concern was water, and this was a data center. So, and for whatever reason, they didn't want to bring the panels down, and I don't remember why, but that wasn't the intent. So in this particular case, and it may have been for, well, maybe it was waterproof in person, I don't really remember, but we created a curb, and we modified our first precast section to accept that curb, and we had our attachment right on the side here. But what this provided for us, and this curb could be any size. I mean, it could be only 3 or 4 inches, and it would do the job. If there's any moisture that comes through because this failed, it would not enter our building, right? It would have to go in this direction. You make this either continuous, or you put a water stop and you pour this after the fact. But this gave us a very clear comfort level as far as water intrusion, because we had our surface at the same level. And in this particular case, we had a rather flat section on this set of drawings. But anyway, you can see how that's able to stop. We were able to put just some masonry flashing, again, to protect any kind of concrete and corner element there. And that's been up for, I would say, at least 8 or 9 years. No issues. When we don't have this, we do get wet. We do get wet concrete and efflorescence on the backside of our precast. So staying with the foundation there, you will typically see grout filling the gap of the precast. It's usually held up, let's say, an inch or so, for constructability, to make sure that we're able to get certain tolerances, or um, reveals to line up. So when you install that grout, excuse me, when you install the grout, understand that most grout needs to be cured, typically for about 24 hours. So a lot of contractors don't know that they need to do that. It's in the installation instructions for a grout, for most grout, non-treat grout, especially for this situation. Um, you can cure it, many different ways. You can put a piece of wet burlap there. You can even use just some curing compound. Since nothing else is going to go against it, it shouldn't harm anything as far as debonding agent. But so, spray a little curing compound on there and call it a day. You'd have to do that on both sides. But grout needs to be cured. Otherwise, it will significantly crack, so even non-shrink grout. So, and you won't necessarily get the strength that you're looking for. So make sure that you take a look at that. It's good to put it in the specs. You're not relying on the manufacturer, and if the manufacturer just so happens to not require curing, they're going to put it in their installation instructions, and then the contractor can bring that up to you. But if you have it in your specifications to make sure that it's cured for 24 hours, at least you know that contractually they're going to be obligated to do it without even having to read anything. So double sealant joints, we really like to use them. We like to see double sealant joints and what I mean by double sealant joints is that there's two sealant joints in the front of the panel. And there most likely will be a third sealant joint on the inside of the panel, right at the inside face of the building. So what I'm saying is a double sealant joint is when there's two sealant joints about 1 inch to 2 inches away from each other. Okay, not just one all the way back on the back side of the panel and one on the front side of the panel. What this does is it gives us the best protection. So this sealant line that's back here, that can last 50 years if you use the right sealant. It won't be subject to UV. It'll be it won't really be subject to moisture. A little bit movement, which it's really designed to do, but I mean, it'll definitely last its lifetime of 20, 25 years, and we've seen it last over 35 years in the restoration side of what I do. So, double sealant joint. One of the things that need to understand, it needs a way for it to weep out, and the back sealant is your primary sealant line. And that's really important to understand, because when you install windows, That back sealant joint is the one that needs to connect to the window primary. Really important. And then this first sealant line is just a weather joint. It's there really to protect it. It's acting as the first line of defense. It will have weeps. Uh, the weeps could be lots of different materials. It could be a mesh. It could be a tube. It could be a hole, but I don't necessarily recommend just leaving it whole. But really, the mesh works really well. But it does need to be wept, and it should happen every other floor at the very least. Okay, so if you have a multi-story building, we did one that was 10 or 12 stories, and we had a weep every other story. So this is what the double joint looks like with a little weep tube. This is actually the building that's 10 or 12 stories, I don't recall, downstate Illinois. And you can see the weep. You can barely see it. You don't notice it, but that second line that's behind it is really doing all the work. In this particular case, the architect wanted the sealant joint to be recessed, which is fine. And so, I mean, it really does produce a nice shadow line that goes along with the precast horizontal elements. This is a weep tube, so you can certainly do a little weep tube. Um, Again, you know, it's up to what you want it to look like. So here's the connection that I was referring to. So the red line is the back sealant joint, and that is considered the primary, or our air water vapor line. Really, it's our air water line. The vapor will be in the backside, but that's the one that should be connecting to the window primary. And in this particular window system, the window primary is back here. The weather joint for the window system for this system is right here. You need to know where your primary is. If the manufacturer did not identify it very clearly on their shop drawings or their cut sheets, then you should have a conversation with the manufacturer. They should be able to tell you based on their testing where the primary sealant joint is, the plane of air tightness. And in this case, it was the shoulder right here. So that's why this sealant line is here. So we had to make sure, and we drew a little diagram for the contractor of what we were expecting. And as you can see, the red line snuck back up before the primary was there, but after the weather joint. So in this case, this weather joint. So we was still protecting this primary as it went up. So we still have two lines of defense, and that primary line will last as long as this, ideally. And then we have our weather joint that was installed later on. So this was just, we have this general sheet that we use for double sealant joints. This is one of them, just to make sure that the contractor, we laminate them, and we like to put it on the stage when we have that opportunity. But just to give them an idea of what we're looking for. So with sealants, you should always test the sealant. The manufacturer should come out. They should do their tests. You want to make sure that what they're installing, it should be the first batch of sealant. It usually takes between 7 and 28 days, depending on the temperature and what type of sealant. The manufacturer will give you a range of when they think it's going to be ready to do the test. Typically, the last part of the sealant curing stage is adhesion. So you don't want to pull it too early, because there won't be any adhesion. And of course, you don't want to do it too late, because you don't want to hold up the job. So always test your joint, and you want to test it to make sure that it's proper thickness. So in this case, the proportions of this sealant joint was way off, and it needed to be removed and replaced. So sealant joints in general have a 2-to-1 proportion, minimum a 1/4 inch, maximum a 1/2 inch in depth. So 1/4 inch in depth is the minimum, generally, 1/2 inch maximum in general. The width of the joint, that can vary. So, and it's a 2-to-1 proportion generally. So if the joint is a 1/4 inch, since the minimum is a 1/4, that will be a 1/4 by a 1/4. If the joint is a 1/2 inch, then that means the depth of that sealant joint should be a 1/4 inch. And what that allows, it allows the ability of the sealant to properly flex and move. So I don't have I mean, it's not really the point of this presentation. understand, know what the proportion should be, and then test it off. And this is 1 inch. So even if this joint was 2 inches, the sealant width would only be a 1/2 inch, not 1 inch. So the ability of this sealant joint to move and flex has been significantly reduced. And when you're doing this, you want to make sure that you give the owner the best possible chance of that sealant joint to last as long as possible. So details are everything. It's really everything in what we do, or I do for my company. So these little details I'm going to go over real quick is to me is like one of the most important things. So this is the backside of a parapet with precast concrete. The architect and whoever designer chose to have the reveal to have oh no, I forgot the name, but an inset, uh, um, a draft large enough where it has like an angle. The key to this is that we needed to get the sealant installer on site and install sealant flush with the concrete in order to install the roofing membrane. Because if our roofing membrane went against sealant that was here, or the sealant wasn't installed at all, there would be a hollow spot behind my roofing, which is bad. The likelihood of condensation to develop, that area is a weak point, and when wind pushes and pulls on our roofing membrane, that area will eventually just let loose over and over, more and more as time goes by. So it's really important that we allow and provide something that that the roofing has something to be backed up against. So we snapped a line, which you don't see here. You see a little bit, but and then the sealant installer was able to do this flush at a certain point. We did a little bit higher than we needed to, just in case for the roofing install. So that's just something that has to be sequenced, but identifying that it's flush in that area is really good to have on the drawings. And then if you have a double sealant joint, and if it's done on the back as well, because these panels are going to be exposed, for example, you remember you need to have that weep, and the weep needs to be located at a height higher than the roofing, right? So if the roofing doesn't go up and over the parapet, and if it stops, 8, 12, 24 inches above the installation level, then you need to have that double sealant joint weep out above it. It's just like a masonry wall at that point. So pay attention to that kind of thing. Another thing is when you have reveals and you're placing roofing up against reveals, right? So this becomes a problem. Again, we have a weak spot right there that could eventually start to propagate and tear itself and then cause issues. Okay, and then eventually you can have the roof fail. Um, it happens, or you can have condensation. There's lots of bad things that can happen if your roof isn't really adhered quite nicely. So understand that if you have reveals, you got to let the contractor know what they should be doing. So in this particular picture, this was in an existing precast building. So this was existing, and we have a new building here. Was not precast. Sorry, guys, but the precast original building was, and we identified this pretty early on in our review that we needed to fill those reveals where we're going to place the roofing and the new wall. So that's what we did. Looks weren't necessarily of a concern with the architect. This is the backside. No one will actually ever see this one, but we were able to do that ahead of time and properly roof it without any concerns. So again, if it's not written, if it's not identified, if your contractor isn't quite diligent to find these kind of details, it's best to have it on your drawings. This is another type of thing we see a lot. We do a lot of schools, museums, and for whatever reason, architects of the past love this aggregate look in their precast concrete. So this could potentially cause an issue when you do roofing here as well. So what we will do in this situation is we'll get some clear epoxy. Um, it's an epoxy grout, and we'll do a strip of it where we're going to be attaching the roofing, and then terminate the roofing too. So we won't have any chance of any kind of water leaking at our at our termination point for our roofing. Now, water can still get in over here, and there's nothing we can do to stop that. But our new installation is not going to be the cause of anything that they currently have that they might have an issue with. The fact that we're creating a little bit of a ledge by putting in a termination here, we don't want to create a situation where snow, water, ice is going to sit on that ledge and then go into this porous concrete here. So we do use I mean, they make epoxy mortar with color. There's clear material as well, which is what we will typically use, or it's a slight yellow or brown color that you really can't notice. But that's something that really needs to be considered. And then, of course, one of the big things, and it's not really in this presentation, but I can tell you when you're looking at an old precast building, we should be looking at the sealant joints. One of the very first things we should be doing. So we should be alerting the owner that their sealant joints may be old. Most likely it hasn't been touched and it should be replaced, during this new renovation, for example. At the very least, you're going to want to replace the sealant where we're going to be roofing and a little bit above that. So again, we don't cause an issue. So keep that in mind. Um, Again, just a little details to think about. So here we have granite veneer at the base of our building, at the base of our precast. And we did a couple things. So here's the granite veneer. And then it looks something like this, but in the building I'm going to show you, we actually had the granite veneer go a little deeper because we weren't sure where grade was going to be. This one, the sidewalk, made it perfect. And the building that I'm going to show you was earth that went right there. So it was some uh, plantings and items like that. So we weren't really sure where it was going to be, but one thing that you should know about these granite panels is, they need to move differently than the precast. This has a different, coefficient of expansion. When the sun hits it, this being black and this being lighter color, these are going to move in different ways. So the precast manufacturer typically knows this. We've learned a lot over the past, I'd say 30 or 40 years from GFRC. Um, and the manufacturers know how to deal with it. One of the things to think about, though, like in this case, is we do have this. There's going to be a gap in general um, to allow for that granite to move. So whenever you have a gap, you have a point of water intrusion, condensation. There's things that can happen, especially when in our case we ended up sealing the joint. So we didn't cast in the granite; we allowed it to move. Um, and again, it depends on the size of the granite, depends on the thickness, it depends on the color. There's lots of reasons why you don't want to just adhere granite to the precast. So again, lots of different ways of doing things, but in this case, that's what we did, and we allowed it to move. So since we allowed it to move, have a gap, we need to consider how we're going to drain this. So we ended up splitting the granite and then having a way for it to water to escape from this top end here above a certain area. So now we did this below grade. Grade is over here. So what we ended up doing in our case, we ended up putting a drainage board covering that joint. So if any moisture gets in here because of failed sealant or because of movement, it would still drain, and it would drain to the drainage board out into the stone that was eventually over here somewhere. So thinking about that really makes a difference whether this black granite's going to have efflorescence, it's going to have cracking, items like that. So you can't bring your precaster in soon enough. So this is actually the detail right there, and you can see the drainage board in this case going over. Here's our joints. You can kind of see the granite below grade a little bit, and the reason being is that there's a big steep off right there, and we weren't exactly sure how this was going to work um, based on grades and stuff. So the easiest thing to do was just to make the panels of all the same size. So anyway, that's what we did. You can see the drainage board, all the drainage board. It just needs, in this case, we just taped it up until we get the final material, the media for the plantings. So we got a nice, our stone base, and again, we were able to drain it properly. Rust staining. So rust staining comes in several different concerns. One is in the actual matrix of the concrete itself. So there could be materials, chert or pyrite. I've had it where the front loader scraped the concrete, and pieces of the front loader got in the mix of the stone. I've had it where it was welding slag got in there because they were welding panels right adjacent to piles of stone, for example. But those kind of things, as far as construction wise, you can somewhat control the front loader, you can control the welding. A little site visit would help that. But certain things no one can really control. We can just test for it and do the best we can. So um, here's a building actually real close to me that has just a lot of this. I just ran across this a job literally within I think 3 or 4 weeks. I was talking to Joe about this a little bit, but it was a warehouse. 5 panels needed to be remade. Those 5 panels had pyrite all over on the interior of our building, and they started to show itself pretty quickly. This stuff can start to show immediately, or it can show, in 10 years. So what we ask all of our contractors and our subcontractors to ask the suppliers is for testing for these materials. Okay, so they should be doing it. They should have certificates confirming that they've tested the aggregates for these types of materials, and then there should be certification from the precaster that they're also reviewing it and making sure it doesn't have it. Now, it's not going to be caught 100%, and there might be a few of them in there, but the less we have, the better. The more we bring this to light, the better chance of us not having this issue. This will go through paint, and then that's what it did on our building up in Ohio. It went through interior on the paint, but it looks terrible, and it's just like a black eye. So again, the best thing we can do, put in the specifications to get the aggregate suppliers to confirm testing, and then the precast plant. Then there's other forms of rusting that we have to worry about. So this is an interior of a building, though the interior of the building in this specific case, the precast was going to be exposed. So it's a grounds building for a real nice institution, and it was exposed concrete on the inside of the building. So the welds weren't properly prepared. It started to rust. The steel, because it was being fireproofed, they were starting to rust a little bit. And then we were getting these rust stains. Now, most of the time you can get it to get cleaned off. Sometimes you can't, depending on the color. Now, don't mind the failure here. That was a different issue that I'm not talking about right now, but right now I'm just talking about the rusting. So here, again, so this is my four-sided, really cool, neat little element at the entrance of that school. And we didn't properly prepare the steel quick enough, and it caused it to rust. Now, we were able to get most of it off, but we didn't get all of it off. And it's a shame. It's on the inside. You really don't notice it. You only notice it if you're like me, or most of you guys on this webinar that are looking for this kind of stuff. But again, mention it, talk about it in the pre-installation meeting, that it should be coded as soon as possible. Don't wait for a painter to come out when you can do everything. That's going to be too late. So we got to make sure that we prevent this as best we can. Okay, so one of the last things that I'll be talking about, the big things, is that precast planks. and floor slab toppings. Precast planks are great. We use it a lot. An interior of a building, we will put some sort of topping on there. We'll use it for roofs, and we require the roofs to have concrete topping as well, which I'll talk about in a second, and why we do that. But one of the things to understand when you have these precast planks, they have a natural camber to them, and although they're engineered to be a certain camber, they're not the same camber right next to each other. It's the camber varies considerably. So when you put a concrete topping, you need to anticipate worst case scenario. So generally, when you do a cast in place concrete topping, the concrete thickness should be about 2 inches, no less than that. Should be 3 times the aggregate size at the very least. If it's less than 2 inches, then you're going to end up with a bag mix, a design mix that is capable of going to a thinner material. But that gets expensive. So I guess my point is that if you're using precast and you're going to put a topping on it, don't just say 2-inch topping. What you want to do is go higher, increase it, because the camber is going to vary, and you cannot pour something with a thin material. It'll end up cracking, which I'll show you in a second. But so we ended up doing a survey, and I highly recommend doing a survey after you do planks. But look at the difference in these cambers. Same span. This one's a little different because I think this was solid, so you got a little 1/2 inch. But this is 1.25 inches, 1.5 inches, 1 inch next to 1 3/4 inches. You can see they vary considerably. This one actually came out pretty good. So this is actually don't. Um, this came out great, but that's the unusual. This is what usually happens. So if I would say a 2-inch topping, it'd be a 2 inch to the 1 inch. So even this one would be too thin, and you would end up having cracking. Your flooring would not survive. So um, you need to really think about that. Now, when we do roofs, there's other things to consider when we do roofs. One is you want to make sure that the roof surface is smooth. If you use a vapor retarder, then that's it's got to be a somewhat smooth surface. So if you don't specify the top of that precast plank to be smooth, it might come out extremely rough, depending on how the precast planks were made. So it is something that you want to talk about. But I can't talk about enough about this 2-inch topping. So here's the condition that we were putting topping on, and you can see in this one that I mean um, just the camera's all over the place. It truly is. So they end up filling these joints here, but it's not really the story that it's really telling you. It's not a flat surface by any means. So again, this one actually was poured in place. It was thin in some areas, and this is what happened. So this is one of the issues. So we had cracking, some of them very significant, some offshoots over there, but it was just too thin of a material. And when we drove on it, which is what we did in this case, it was a drivable floor. It displaced and it cracked, and it just kept going over and over until we fixed it. So again, you can kind of see it on this picture. Wish it was a little bit better, but you can see how it even settled just a little bit differently. So this is actually the finished topping that it's right here. So it's between these two materials. So here's a roof. The yellow dotted line is a straight line. So you can see, I blew it up here. You can see it's 1.25 inches difference. So there is that slope. Insulation is not sloped. It's pretty rigid. It's hard to get that on that slope. We ended up putting a concrete topping in order to get that nice and flat. So it is something that really should be considered in the overall cost. Last item, I believe it's last item, is window connections. Everyone wants the insulation to go from end to end. We don't want a thermal break in our precast. The problem is that when we connect windows, we really should have a solid element. Or what we can do is we can offset the insulation. We can offset the insulation. So in this drawing, you can see where we found out where we be connecting the windows. We offset, and we still have an insulation plane, so we don't lose our thermal concern, but we have a solid connection to concrete for our window. So it worked out really well. It was just a minor tweak in the overall design from the architect, but after explaining the situation, totally understood, and we still were able to, do that thermal break really well. Another thing is, you may need to bring out that window so far back in order to get the connection because of that insulation. So we use generally use the structural fiberglass angle, again because of the thermal concern of too much metal in the situation. The last detail, actually this is the last detail, is the steel beam and joist concern. Is that when you have a steel joist that embeds into the concrete panel, there's this void. So those voids. This void is very rarely on the drawings. It's not identified a lot, and whether the void is a square or whether the void is a slot depends on how it's going to be constructed. So if these are real long, let's say 100-foot trusses, they might go into a slot on one side and then go down on the other side. So one side might have this slot or this hole, and the other side will have a slot in order to install the joist. But very rarely do I see the drawings address this concern. So a couple things, we did spray foam here, and then we covered the spray foam in a metal. We needed to cover the spray foam in the metal from below too, because you can't have exposed spray foam in a building, generally, depending on the building type. But so instead of using intumescent or a fireproofing on the underside or backside of this insulation, we decided to cover it with metal. We ended up using, the 22 gauge. You can use stainless steel if you have a thermal concern, but there's things that you can do. But that's how we solve that issue. How you solve it, it's up to you. I don't recommend bats, and I don't recommend rigid insulation because these things may not be perfect. If you don't get that rigid insulation and nice and tight, this is very good chance of condensation to develop right here, and then you'll get dripping, and then it'll just streak down your building. Based on my experience. So anyway, something to consider. Take a look at it and ask how is the steel being installed, and then how you can address these things. And so that was the last detail. This is just the last thing is, um, sometimes, well, wait, ahead of time. Sometimes you'll have a three-sided panel. Those need to be talked about with the precaster, how he's going to do that, what he feels is best to make that work. Generally, forms are how these precast panels are installed. So you can only finish basically one side. But if you have three sides of prominent precast that you want, you really need to have that conversation. So the forms could be built correctly, so the contractor is able to adjust for that. If you have any kind of reveals or finish difference, that could be discussed and how that works. This is a three-sided precast that turned out really really well. And then this is my four-sided one that we talked about. This one, the guys did a great job doing this. It's got reveals on all four sides. I mean, they just did a fantastic job making that work. Just a little detail, it did cost a little bit, but I mean, design element, I thought it was real playful for what the school was, and I thought it worked out really well. So limitless possibilities, even things that you wouldn't maybe think it's easy to do. These precasters can do almost anything. So, and that is it. That is it.
Great.
So Joe, you're there. There you go.
Yeah, thanks, Corey. Let's start answering some questions. We do have a couple more minutes here. At 1 o'clock Central, you guys have met your time constraints, so you're more than welcome to stick around for a couple more questions or jump off the call here. We'll jump into the first question. It's in regards to some cold weather conditions. Precast in our area is sometimes erected in cold weather conditions. When areas are grouted, what recommendations beyond using hot water in the mix is recommended?
Yeah, so we do it all the time. We're in Chicago, and we do a lot in the Midwest. So warm water, of course, that is. But we end up using blankets and plastic. So what we'll do is we'll put plastic first, generally black plastic, and then we'll put blankets. If it's super cold, like it was in Chicagoland or around this area, we just wouldn't pour it. So really anything below 15 degrees we won't do. But we've had really good luck with maintaining temperature with using black plastic, and we would use like an R8 to an R12 blanket. So we would require multiple blankets depending on what kind of R value your blankets. But we've been very successful with that. If it's really bad, you could always use a ground thaw on top of the blanket to keep it super warm. But we haven't had a need to do that.
All right, great. We'll get two more questions here. Then any other questions that have been submitted, don't worry, we will answer them offline. So your questions are not going unanswered. Another question in regards to sealant. If I choose to use contrasting sealant color on a light colored precast, should I be concerned about any potential color bleed?
So if you shouldn't, but if you are concerned with any color bleed, most sealant manufacturers make um, a, a primer that is designed to block any kind of migration of chemicals. So we used to have this problem in stone. So granite installation, when granite and marble was the big thing to put on high rises back in the 80s, we would get a lot of migration, chemical migration into the stone. So the sealant manufacturers designed a primer to stop that. And we haven't had any issues since for decades now. So if you are concerned and for using a lighter color precast, it won't hurt. And most manufacturers have that primer that will solve that issue.
Perfect, thank you. Last question. And do you refer to the language and data in PCI MNL 116 or MNL 117 for acceptability and expected variations and finishes? And if you need some help answering that one, I'm more than willing to.
Yes, I will. I'll do my part, then I'm going to refer it to you, Joe. So I did talk a little bit about it in part one, 16 and 17. I know that there are new standards as well, and Joe's going to talk about how those integrate each other. But generally, 116, I believe, is industrial, and 117 is more architectural. And there are more variations now. So I'll let Joe take it from there. Otherwise, I'll mess it up, I'm sure. Joe?
Perfect. Nope, you hit it. MNL 116 hits the structural wall panel section, and if you're going to have any architectural finish, MNL 117 is the best to do it. Again, have that conversation with your precast early on. So with that, we're going to wrap it up. Thank you again, Corey, and thank you everyone for attending today's webinar. You should receive an email with a link to your certificate of attendance within 10 business days. Thanks again for joining us.